Kronos team, SRE squad, and I'm working as a DevOps engineer. So today we will be discussing about my side experiment KubeEdge. KubeEdge is an open source project which extends the Kubernetes environment to the edge devices, which enables the deployment and orchestration and management of our container application at the edge side.
Start.
So let me take you to the problem statement. While working on my last project, we have IoT devices at edge locations which gather huge amount of data and send it to the cloud side, on which we perform ETL operations. But in this case, we face few challenges like latency issue, resource allocation and optimization at edge side. Also, the development and deployment of application at the edge nodes. So let's move to the solution part. So we bring Kubernetes in our project environment, which helps in bridge the gap between the cloud computing and edge devices by bringing the Kubernetes abilities of scalability, portability, and containerization to the edge side. So KubeEdge allows for distributed computing, storage, enabling the real-time data, reduces the latency and enable performance to the edge nodes. And also helps in enabling the alerts to the edge devices, which helps in monitoring all the issues which are going on our edge nodes. So let's move to the implementation of KubeEdge. So this is the whole architecture of the KubeEdge, and I will discuss this how we implement this whole KubeEdge architecture in our project. So let's move to the architecture. So basically, we have two major parts in our KubeEdge architecture. The first one is the cloud part, which we call as cloud node, and the second one is edge part, we call as edge node. So we have few components in our cloud part, which is Kubernetes API server, we have edge controller and cloud hub. So basically, edge controller records the metadata and all the manifest and all the records of pods and deployments in our cloud node. So Cloud Hub is responsible for the linking of pods and deployments between the cloud node and the edge node. In our edge part, edge node, we have edge component, which is responsible for maintaining pods, probe events, configure volume. So it have a capability to maintain all the resources running on edge node. So Meta Manager is the mediator between the edge component and the edge hub. It manages the manifest and records all the communication data between the edge and the edge hub components. So here we have event bus. Event bus is responsible for communicate with, through the MQTT protocol between the IoT devices and sends data to the edge node. And here we have device stream, which is responsible to store data in our small database like SQL. So the device stream is directly in contact with the edge hub, through which edge hub syncs all the resources from the cloud node to the edge node. So KubeEdge uses the MQTT protocol, which helps in reliable and efficient communication between the edge node and the cloud node. Also, MQTT protocol uses the pub/sub model, which helps edge node can subscribe to a topic and push their message there, so that cloud services can publish to that particular topic and receive all the messages from there. So this pub/sub model of MQTT broker provides a seamless communication between the cloud node and the edge node, and also facilitates the better communication and the data transfer between the edge node and cloud node. So in this diagram, we have better visual of cloud node components of KubeEdge architecture. So here we have edge controller. Edge controller is also responsible for managing the edge node, and also it collaborates the app metadata with cloud node and the edge node. So in moving to the next part, we have device API, or we can see it as a device controller. So it is also responsible for accessing and managing edge devices running on edge node, and also collaborate the device metadata with cloud and the edge part. So next part we have is sync controller, which is responsible for reliability and consistency of data transfer between the cloud part and the edge part. So let's move to the use case part of KubeEdge. Here I am considering an example for use cases. So I am considering an example like devices on bridge. So we have 5G antenna here in the bridge, which is located and which is built on the bridge. So here we have IoT device. We can say we have sensor which is placed over the antenna. So here we have edge node, edge box. So the data we collect from the sensor or from the IoT device will all transfer to the edge node, and then edge node will transfer and synchronize between the cloud node, cloud part. So this is the first example which we consider as a use case, the sensor or antenna over the bridge. So this is the second use case which we are taking for KubeEdge. So we have vehicle cloud collaboration platform. Suppose we have a vehicle, and here we have our cloud node running on KubeEdge. So we have edge devices or the IoT devices running on our vehicle. Suppose these are the devices for like you can think like it could be a temperature sensor or a speed limit warning. These are the sensors which are connected to the mapper through the MQTT protocol. Also, we have applications running here in the KubeEdge node. So they are responsible for gathering the data and then send it to the cloud node part. So we can consider it, we have a large scale scenario, we have so many vehicles and devices. So it can also handle the thousands of or millions of vehicles per cluster. So we can easily manage these millions of vehicles as it has lightweight architecture of handling all these traffics. Also we have flexible expansion, like we can handle multiple Kubernetes cluster, and we can customize endpoint rules and channels. So we can also implement KubeEdge autonomy, which is responsible. Like suppose we have we get offline from the our cloud node. So edge node can offline handles and make decision making changes for the data which we have present on our edge node. And when the cloud part or the communication between the edge node and the cloud node gets reconnected again, it transfers all the data and update it to the current metadata scenario. So let's discuss about few benefits and advantages and key features of KubeEdge. It has seamless extension of Kubernetes to the edge, distributed processing and analytics at the edge, reduced latency and improved performance, real-time decision making and making capabilities, efficient utilization of edge resources, scalable and portable containerized deployments, integration with cloud infrastructure, simplified management of edge nodes and devices. Also improve reliability and resilience at the edge. KubeEdge is beneficial for customer in several ways. Like it is easy to use, it takes very less resource to be run on edge node as well as on cloud node. So it uses very reliable connection, so there will be less latency and there will be no chance of data loss. Also it manages the resources very well between the cloud node and the edge node part. After using KubeEdge, customer will also get benefits like real-time data processing, manages the local data, and it facilitates the seamless coordination between cloud and edge part. KubeEdge is a great tool for learning and use it in our day-to-day life, as it reduces many major problems like reducing the latency issue, gives us the bandwidth and the seamless data transfer and the resource management between the cloud and the edge node. So being a DevOps engineer, we really need to grow with this fast-paced world by learning new technologies which is coming day by day. So I'm thankful to my organization XenonStack for giving me such opportunity to learn, to give me a chance to learn this KubeEdge tool. I learned a lot about this tool and learned about how to work with the edge nodes and edge environment with IoT devices. Thank you for watching this video.